Welcome back to ArmanisMath. Today we're going to discuss the exponents and in particular the nth roots, radicals, and rational exponents. There's a lot of exponents ideas we're going to discuss today. Here's the objective of the day. I will be able to relate roots and rational exponents and use them to simplify expressions and solve equations. Let's say that I have 5 to the second power. How much is that? I need a lot of participation today, okay? So, as I said, use the live stream comments or the chat or the private chat. But here we go, 25. Okay, how much is square root of 36? Awesome. Okay, and how much would be 5 to the negative 2 power? It looks like someone is not happy, and this guy here is not happy because it's negative. Exponents do not like to be negatives. They don't like that. They want to focus on the positive in life. So what do? You flip the base. You do the reciprocal of the base. So this is 5. It becomes 1 over 5. And the power now is happy. So there's a green color for the power for the hour. And now that 2 belongs to, this 2 here is going to belong to both the 1 and the 5. And basically you're going to say 1 to the second divided by 5 to the second, which is, excuse me, 1 over 25. So keep that in mind. If you have negative exponents, you have to flip the base. You've got to flip the base for negative exponents. So I've got 16 raised to the 1/4. 16th to the 1/4 power. Excuse me. And before I touch on this topic, I'm going to review again what we talked about the previously, and that is the fraction. When you have a fraction as an exponent, you basically are looking for some roots for the number that you're raising the exponent to. And in this case here, it's always the bottom that determines the root. So basically you're looking for the 4th root of 16. You put that in the radical expression as 4th root. So the index for the radical here is 4. The radicand is what's under the radical, which is 16. And then you're going to ask yourself the question, what is the number that is multiplied by itself 4 times that gives me 16? That's the 4th root. Means number by itself 4 times gives you 16. And the answer is 2. And that's it. You just solve the question here. So let's try something else. I'm going to try 27 raised to the 1/3. 1/3. That would be what in terms of the radical? Third root, thank you, Yushi. Third root of the number, which is, I've got 27 here. So third root of 27, which is, again, they're asking, what's the number that you multiply by itself 3 times, because of that 3 here, third root, 3 times, gives you 27. And the answer is 3. That's true. Okay, looks like we're doing good. Now, what if they want to spice up this issue a little bit, just a little bit spicy? So what if they said, for example, we want 27, but this one's going to be raised to 2/3. 2/3. Okay, well, let me think a little bit here. There's 2 ways you could do this. I'm going to put that actually in the middle here. 27 raised to the 2/3. There's 2 ways I can do it. I either could use the radicals, or I actually could use exponents as well. So I'm going to try with the radicals first. I'm going to try the radical method first. So I'll go here. I'm only going to deal with radicals, okay? So I'm going to say this is the, what kind of root here? What kind of root is the 2/3 here? Third. It is third root of 27. However, there is that 2 is outside here waiting for me. Because 2/3 is like 2 times 1/3. Keep that in mind, okay? 2/3 is that amount. So 2/3 is just this. You also could make this a fraction if you'd like. 2/3 is 2 times 1/3, or 1/3 times 2. So now let's go back here to radicals. You just gave me the answer for this one. The cubic root of 27 is 3. And that is raised to the second power. Well, what's 3 to the second power? Come on, champions, you know this. 3 to the second power is what? 9. And that's the answer, okay? That's not the only method. There's another method that you could try, which we're going to do right now. We're going to deal with this matter in terms of exponents only, okay? So I'm going to have to think a little bit here. What kind of base does the 27 has? Is it a 2 raised to a power? Or is it a 3 raised to a power? Is it a 4? Is it a 5? What do you guys think? What's the base for 27? It's a 3 raised to the third power. That's what 27 is all about. 3 raised to the third power, okay? Now I have only unfolded 27, so I still have that 2/3 outside waiting for me. What about me? What about me? Okay, take it easy. So the issue now is to get this number here to talk to each other. If you have an exponent, and then you also have another exponent outside the parentheses, basically you're multiplying exponents. You're multiplying exponents. So in this case, I have 3 times. Do that with me here, on the side. 3 times 2/3. 2/3. I could make this 3 a fraction, by the way. So like this. And then I'm just going to see if I could use my fruit ninja and then try to simplify. And I'm left with 2. So 3 times 2/3 is going to give you 2, which means 3 to the second power. What is 3 to the second power? Champions. 3 to the second power is how much? 9. And that's it. That's the same answer. It has to be the same answer. Just different method of reaching out to the same destination here. You tried the radicals, which is perfectly fine. This 2/3 has a 1/3 at the bottom, right? 1/3 times 2. So here's a 1/3, which is a cubic root, and then to the 2, second power. And I got the 3 raised to the second power is 9. Or I could also dissolve this 27, break it down to its component, which is 3 to the third, times the exponent, which is 2/3. And then I did the fraction multiplication on this side, which enabled me to simplify, and only left with 2. I only have 3 to the second power, which is 9. All right, champions? So now let's do another one. I feel like we need one more of this. What do you guys think? One more? Give me a yes if you need another one of this. Yep, me too. That's how I feel. Yep. Okay, let's take a look at this example. This one's going to be 32 to 2/5. 32 raised to the 2/5. Okay, well, again, I'm going to think here a little bit. 32 to the 5th. Okay, let me try radicals. Okay, I'm going to try radicals. I'm going to try to solve it with radicals. So I'll put the 32. What's the root here for 32? What kind of root I'm expecting for 32? Okay, it's going to be the 5th root, and that is true. By the way, don't forget to subscribe and smash the like button and share. To the 5th root, so I have 5th root here. But this whole thing is raised again to what power? Second power. Because this one here is like, again, 1/5 times 2. So I got the 1/5 here, but I'm left out with the 2. So what's that number that you multiply by itself 5 times and you get 32. What would be that number? And if you're on the live stream, you will see something that is very interesting right now. Shh, don't tell anybody, okay? Okay. You saw Among Us. Oh, I just said that. That's a 2 raised to the second power, which is a 4. Okay. Now let's move on to this one. What if I want to do this in terms of or using exponents only? I do not want to use radicals. By the way, you need to be expert in both of them. But I'm just saying there's another way. So how do I break the 32? What's the base of 32? Can somebody tell me what's the base of 32? Yo-yo. What's the base of 32? Could it be... Hello, somebody's typing here. 5 is way too big, right? The base, if I put 5, that means 5 to the first, that's 5. 5 to the second is 25. 5 to the third is 125. Oh, that's too big. That's too big. 5 is too big. 2, thank you, Lindsay. 2 raised to the 5th power. That's very true. 2 raised to the 5th is going to give you 32. Okay, so now I got the 32, but now I'm not going to neglect that there's a 2/5 waiting for me outside. There's an exponent 2/5 here. So how do I do that? Well, again, you just multiply. Here you got 5 times 2/5. You could make this guy also a fraction again. Get fruit ninja ready and chop chop. Ka-chop. Ka-chop. It's going to leave you with 2. So I'm going to go here and say 2 to the second power. And what is 2 to the second power? What would be 2 to the second power? Yep, that is the answer. 4. Okay? So that's what we do for these cases. Either you could use the exponential exponents primarily, or you could also use radicals, which is kind of more options to you to have. Okay, now I'm going to move on to something else right now, which is a different, almost same idea, but a different example. And let me start with this one here. Keep track of examples, you guys. Keep track of the example numbers as well. So I believe this was example. This was the warm-up here at the top. So you might want to put this one as example 1, example 2, example 3, if you're numbering your examples, and 4. And then we're going to do example 5. This one has interesting thought, and this one has a negative exponent, okay? So I've got 27 raised to the negative 2/3. Okay, that's very interesting. Let me give myself more room for 27. 27 is the base raised to this amount here, negative 2/3. Well, right off the bat, you know one thing, right? I really should not be having negative exponents. I know that for sure. This one is not a good thing. So I need to fix this. So I fix it again by doing what? Does anybody recall? Does anybody remember how you fix the negative exponent? How do you make it happy? Multiple users are typing. I love that. You flip the base. So that becomes 1 over 27 raised to the 2/3 power. Now it's green, and now it's doing fine. 2/3. Now, this 2/3 apparently belongs to the 1 and belongs to the 27. So I'm going to go the same route as we done before. It's either you're going to do this exponentially, or you're going to, with exponents I should say, or you're going to do this with the radical. So maybe on the, be consistent here, so on the left side I'm going to do the radical, meaning I have cubic root, it's really long cubic root, very tall, of 1 over that, of 1 over 27. The whole thing is raised to the second power. Whoa, why did you know that, Armani? Well, I looked here. 2/3 again is the same as 1/3 times 2. And the 1/3 is a cubic root. I took the cubic root, and what's left is a 2. So now you're going to say this is a cubic root of 1. Just split the cubic root to the top and bottom, and cubic root of 27. You still are raising it to the second power. Is okay. So now 1 cubed is 1, right? 1 square, cubic root of 1 is 1. It's always that. So that's not going to affect the 1. At the bottom, however, cubic root of 27 is going to be a 3. And I still have to deal with the 2 outside. Okay. So now we could distribute that 2, because that 2 belongs to everybody who lives in this household. It's the 1 to the second power, right? Which is 1. And the 3 to the second power. 3 to the second. And that's going to give you a 1 over 9. Okay? That's one way to do it. That's one way. There is obviously the other way. The other method is going to be dealing with this in terms of exponents. So let me scoot up a little bit here and see. Look at the problem. I'm given this problem here. So I could actually in terms of exponent, a little bit easier maybe is to deal with it right at the get-go, at the beginning, right here at the beginning. So I'm going to put the problem, the original problem here. So 27 raised to negative 2/3. Okay. There is a different school of thought here, but I'm going to just cut through the chase and tell you, you are actually able to now, in this case, to start by having the base here. So I could say this is a base of 3 raised to the 3rd power, and then have the negative 2/3 still negative 2/3. And then I'm going to multiply these guys here out. For example, what I'm saying is 3 times negative 2 over 3. See that? I did not change the negative yet. That's still here. I said I'm probably going to wait for it. As I said, there's just different school of thought, but this is one of them. And I'm going to use my Fruit Ninja fraction. So this is going to go away, leaving it with negative 2. So basically, you're going to have 3 raised to the negative 2. Well, what is 3 to the negative 2? Well, first you have to make this guy positive, right? So I just have to take the reciprocal of that, and that's going to be 1 over 3 to the 2nd power, which is, again, screwing this over a little bit here. 1 over 3 to the 2nd power is basically 1 squared divided by 3 squared. 3 squared, which is 1 over 9. That's just another way to approach the problem, okay? You could choose either, but make sure that you're familiar with both of them. So let me recap this for a second here. So we started with a problem that has a negative exponent here. And we said, well, if you want to do it with radical, you need to change this negative exponent to positive 1, and I did. I put that here, by the way. Then I said I could do it with radical here. On the left side, I only dealt with it with radical. And I put the cubic root of 1 over 27, which means I have a cubic root of the top and the bottom, numerator and then denominator. And then that was raised to the 2nd power, and then distributed the power. And then I found myself looking at 1 over 3 squared, which is 1 over 9. You also could do it using exponents. And also, as I said, there's a couple school of thoughts here. You could actually make this guy positive and then keep working. A little bit easier in this case to multiply, to find the base first and then multiply and then get rid of the negative. But both should be fine. Okay, champions? All right. Do you think we would benefit from another example like that? Yes or no? Yeah, I think so. So let's do one more example like this, which would be example number what, by the way? What's the example number now? 6. All right, here we go. Now this one is going to be a little bit easier, but again, I've got negative, and then open parenthesis 16, close 3/4. 3/4. 3/4. Ay. Hold on one second. Need to give myself more room. 16 needs to be all the way at the bottom here, and then 3/4 at the top. Okay? So 16 raised to the 3/4. But there's a negative outside here. Negative that. All right, champions. So I've got this amount here, and I need to simplify. Well, first thing first, there is nothing that I could do about this negative. If this negative is in parentheses, yes, I could do something about it. And obviously, if you have some powers here. But if it's not outside, if it's not in parentheses outside, that means it's just something, an issue outside the family. It doesn't affect the family. So I'm not really going to be concerned that much about it. So, which means I really have to carry this with me without doing any operations to it. So I am looking here, and I'm also going to do it in 2 different ways. I'm going to say this is negative. And what do you think is the root that we're talking about here? What root are we talking about here? What's the root that I'm going to use? I need you to talk to me. What kind of root in this case are we using? What kind of root is this? That is the 4th root. 4th root. Why 4th root, Armani? Well, remember, it's that denominator that determines the root. So I have 4th root here. So there's a 4 here. And then I have number 16. But the whole thing is raised to the 3rd power. Why is that? Well, because again, 3/4 is equal to 1/4. That's the 4th root times 3. That's why. So now the question is, this, by the way, this negative, I'm going to just put it a little bit far from the family. And then I'm going to just drop it the way it is. Negative is going to just drop the way it is. Negative, because it's not inside the parentheses. So now what's the 4th root of 16? What's the number multiplied by itself 4 times gives you 16? Stay focused, you guys. Here we go. So I need more than just a couple. Yep. 2 is what I get for this, but I still have this guy waiting outside. What about me? What about me? Okay. We're going to get to you in a second. 2 to the 3rd is how much? What do you guys think? What is 2 to the 3rd? What is 2 to the 3rd? So it's negative, and then we have 8. Recall in this, if you actually paid close attention, this negative was not really affected by anything here, because it was outside the parenthesis. If it's inside, we have something else to do. Also, we need to do this one. Let's try this one in radical form. Okay, I should say exponential form. And this one exponentially. How do you break the 16, by the way? How do you break the 16? What's the base for the 16? Number raised to what gives you 16? It could be 4, right? 4 times 4 to the first part is 4, 4 to the second is 16. Yeah. 4 to the second is 16. It could be 2. 2 to the first is is 2, to the second is 4, to the third is 8, to the fourth is 15. I'm just trying to think out loud here. Because if I could put 2 to the fourth, I'm able to cancel the 4's. But 4 to the second, I could get to it, but at the same time, there are some issues with me not being simplified all the way. So I'm going to stick with the simple one, the 2 as my base to the fourth. Again, what did you do this, Armani? 1 at 4? Well, I'm trying to cancel this 4 here. See that 4? Times 3/4. And I'm going to do the work on the side. I'm saying here 4 times 3/4. So again, make this guy a fraction. And then just chop chop. You have 3. 2 to the third. 2 to the third. Basically is what you're going to get. And remember that you have a negative for you outside. This negative just drops the way it is. -8. Okay, that's just a thought on this example. Give me a thumbs up if you're doing good. Give me a thumbs up if you're doing good here. If not, then definitely tell me something else. You have the live stream, you have the chat, you have private chat. There's a lot. You have your whiteboard. There's a lot of ways that you could reach me for help. Okay. Okay. Let's move on to another item, and this one is going to be equally amusing. This one's going to be a little bit chubby. It's on the chubby side, which is totally fine. We could do that. We could do that. Here is my example 7. This one goes like this. This one says you have a cube. Is it a cube? No. It's really humongous looking thing. It's the fifth root of 32 M15. Interesting. How did you get that? Well, again, it's just a little bit chubby. Did not eat healthy. Stayed at home. And blame it on the pandemic. No. We are going to eat healthy even if we are staying at home during the pandemic, okay? We're going to sleep well, because sleep also makes a difference. So how do you solve this? How do you simplify, I should say? Simplify this. Well, again, I'm going to break it to its components. I'm going to divide and conquer. So if I took the fifth root of 32, multiplied by the fifth root of m to the 15th power. Can you have a power under the square root? Yeah, of course you could. But we're going to simplify it in a second. So what's the number multiplied by itself 5 times give you 32? What's that good number that we looked at? That's the 2. 2 to the 5th is 32. What about 5 to the 15th? This one needs simplification. So I have 5 m 15th times. What do you think is the root I'm going to put here? What's the fraction I'm going to put here? If we want to go from radical to exponential, what would the fraction be here? Come on now. One-fifth. Yeah, this is a 1/5, right? 1/5. So it's the fifth root, 1/5. So basically we're saying 15 times 1 over 5. Well, you could again make this guy a fraction, and then 15 and 5 would be 3. So you will end up with m. 2 is going to stay the same. This m is going to be m to the 3rd power. So just 2m to the 3rd power is going to be the result of this simplification here. If you simplify that, that's what you're going to end up with. Right, champions? That was number 7, and let's do a little bit more, okay? I feel like we need to do some more of these chubby ones as well. Here's an example, number 8. Ask me questions again. Ask me questions. Let me check on the chat here. Okay. Okay. This example is also interesting, and we're gonna take a look at it. And this one, it goes like this. Now you're gonna try to help me, okay? It's also a bulky, chunky radical, and this one is a fourth root of x. This is the 4, by the way. Of x 20, x to the 20th power, y to the 8th power. Okay, how do I do that? Go ahead and try this on your own for a second. I'll give you a couple seconds here and tell me what you're gonna do. Try it on your own for a second. And don't share the answer yet. Okay. Once you find it, do not share the answer. Yet. You could share the answer with your screen if you'd like. Okay, I'll give you a minute for this. One more minute. Ryan, I see that. That looks impressive. Yep, that's it. Anybody else can compete with Ryan? Competition is good. Anybody else? Andrea? Olivia? Brianna? Juliana? All right, go ahead, you guys start sharing your answers. Either the screen or the chat. Hello. Somebody was trying to type and then you guys stopped. Is everything okay? Is this a delay in the chat, or you are not confident? Because remember, in here we share thoughts. Doesn't have to be correct answers. You're just sharing your thoughts. Brianna, what you got? Juliana, Kathleen, Olivia, Andrea, David. What's your take on this? Okay. Okay, Brianna, help me out. What do I need to do here first? What's the first thing I need to do? To that and to that. Okay, Myra. So, Brianna, do you think I could do this here? Separate the radical? Is it a yes or a no? Yep, that's the first thing I do. 4th of y to the 8th. And basically I'm gonna make this guy a fraction, right? So x 20th power raised to the 1/4, right? y 8th raised to the 1/4. And if you look closely here, 20 over 4 is 5. That's x to the 5th power. And y 8 over 4 is 2. That's y to the 2nd. And voila, that's it. That's all it takes. Simple as that. Okay, champions. Now let's move on to number 9. Number 9. And this one will be, let's see if we could have a chubby one as well. Yep, we have a chubby one here. Can somebody tell me what times itself 4 times that gives you 256? A number times itself 4 times that gives you 256. Are you thinking about that number? It's a long, chubby radical here. Does anybody know that number? Okay, 4 times. It's so if we could try. I mean, 8 times 8 is how much is 8 times 8? 6. Hello? What's 8 times 8? Champions, I need you to be ready. 64 times 8, that's way too big. Someone has choose the other choice here. Good thought. And that's going to be my a smaller base, basically, is what we're looking for. So a fourth of 256, which is going to be 8. Fourth of x is 12. Fourth root of y to the 24th. And again, if you remember, this is x12 raised to what power? Somebody tell me. x12 raised to what power? All of us should know this by now. What's going to be my power here? Think again. What is the root that we're trying to have here? What's the root here? What's the root that we're dealing with at the moment? Good, except I can't just put the 4, right? It has to be, it's the 4th root. So I have to raise this one to the, looks like somebody's typing, to the 4th, right? And also, that's going to be the y to the 24th power. That thing is raised to the 4th as well, because it's the 4th root. And with simple math, again, we've done a lot of these today, so I'm not going to go over this fraction. So 12 times 1/4 is x to the 3rd, and y, 24 divided by 4 is how much? What is 24 divided by 4? 24 divided by 4. 6. Okay. Wow. We've covered 9 examples today. You guys should keep a track of that link that I sent you. There's 9 examples here. 9 examples. Okay. Now to move on to solving equations. So we're gonna solve equation with the nth root. Solving equation. Solve. The word solve means you have to come up with a solution for a variable. Solve. And then I've got this example. I've got 2x to the 5th power equals 64. Okay. Well, first thing first, I need to isolate the variable. Isolate means you put the variable on one side and everything else on the other side. So apparently what really bothers me at the moment is the 2, right? Exactly. So I'm going to have to divide by that 2. Divide what by 2? Divide both sides by that 2. And because it's an equal sign, whatever you do to the left, you do it to the right. That's going to be x to the 5th equals 32. And I know by now that x to the fifth could be, I have to take the fifth root of that, right? Get rid of that by taking the fifth root, and also the fifth root of that. I'm going to give myself room here. Take the fifth root of that as well. Well, fifth root of x to the fifth, you now know why does it cancel, right? Because again, x to the fifth multiplied by 1/5, x to the fifth. I'm going to be consistent here. Give me a second. X to the fifth multiplied by 1/5, or I should say raised to the 1/5 power. 5 times 1/5 is 1. That's why this whole thing is cancelled and leaving you only with x. Now you know why the square root cancels the square, and the cubic root cancels the cube, and the fourth root cancels the fourth power. That's why. And then now the question is, what is the number that is multiplied by itself 5 times that gives you 32? What could that number be? That number came up more than once today. What could that number be? The number by itself 5 times, that could give us this good looking answer here. X equals 2 is the answer to this problem. Okay, now let's do another one. Okay, I feel like we need to do, was this number 10? This was example 10. Yeah, let's do one more. I'm going to close with this example. Okay, this is example number 11. Solve again. Solve. And this one is 5x cubed equals 320. 5x cubed equals 320. Okay, what do you think we should do? Give me some ideas. Maybe I should give you time here for this one. I'll give you about a minute. Okay, so again, if you're watching the live stream, you'll see something nice that I just added right now. Keep it hush hush for once you find your answer. Keep it hush hush, okay? Okay, time is up. So let's see what you guys have. Who wants to share? At least the approach that they have tried, if not the answer. So, what did you guys do? Or what would you like to do? Okay. What is 32 divided by 5? What is that? What's that number? (64). Okay, so I've got x cubed equals 64. And what is the number that is multiplied by itself 3 times gives you 64? Here we go, 4. So you take the cubic root of both sides. You take the cubic root of both sides. Cubic root of both sides. and you'll find out that your x is going to be 4. Right, champions? That should conclude this session. So stick around for over here. The first one is the product property. What does the product property says? Well, if you have, let's say, x to the second times x to the third, that's going to be x2 plus 3, which is x to the fifth. So basically, if you have the same base with different exponents and you're multiplying, you basically have to add the exponents. They did it here with fraction, and that's why I give you a whole number here, so I don't have to worry about fractions. But same thing with fractions. 4 to the 2/3 times 4 to the negative 1/3, you just add them up. 4 to the 2/3 minus 1/3, or basically 4 to the 1/3. And the second property is the quotient property. Quotient in math means division, and product in math means multiplication. So quotient is something like, they have a simple example here for us. 3 to the fourth divided by 3 to the second, because you have the same base, then you could just subtract the powers. It's 3 to the 4 minus 2, or 3 to the second power, simplified as 9. The power of power, that's interesting. We dealt with this last session, right? When we multiplied what's outside of parentheses with what's inside the parentheses, right? You guys remember that? So here's an example. Let me do, for example, x to the second raised to, I'm going to say, for example, here to the fourth. Well, this power of power says, because there's a power here and there's another power here, it says you just multiply x to the 8. Or if you want to look at the example that they have here, 7 to the third raised to the 2/3. Well, this is when you use your fruit ninja and then chop chop with the 3's, and then you're going to end up with 7 to the second. What is 7 to the second? 7 squared. What is 7 squared? 7 squared is how much, you guys? I need all of us to participate. $49. So you could put 49 here. Another power. So what this was the number 1 power, I should say, property. Second is quotient. Third is power of power. Fourth is the product, or power of a product. What does that mean? You have a product, which means multiplication. 2 things multiplied. In this case, 2 things. And then you have power raised to that. So if I could give example of that, that would be something like, let's say x and y. The whole thing is raised to the third power. Well, this is basically goes back to the concept of you distributing the power. This power belongs to both of them, to the x and to the y. So that's why you're going to end up with x to the third power times y to the third power. Power of product. What they did here is they have 16x raised to the 1/2. Well, the 1/2 is going to belong to the 16, so 16 to the 1/2, which by the way means the square root of 16, and also the 1/2 belongs to the x. I know the square root of 16, which is 4. I do not know the square root of x because it's variable, it's unknown. So that's why I leave it the way it is. Negative exponent, well, we also talked about that briefly. But if you have a number, if you have, let's say, for example, I have 2 raised to the negative 3. Does anybody remember from last time? Who's not happy here? Can somebody tell me? Who's unhappy here? Yo, who's unhappy here? The negative 3 is unhappy. And I make that happy by doing what? Does anybody know? Hello? I make it happy by doing what? Flipping the base. I flip the base. It becomes 1/2 to the third. Right? Everybody's going to be raised to that third. Which, again, is 1 to the third and 2 to the third. So it's 1/2 to the third. Or, this is 2 down here. 2 to the third. Or 1/8. what they did is they chose an example with a fraction, which is fine. So 5 raised to the negative 1/2 is going to be, you flip the base again, so that becomes 1/5 to the half, basically. And I'm going to distribute the half. 1 to the half is 1, 5 to the half, we just leave it the way it is. Okay? This was going to be 81 to the 5/6 times 81 to the negative 1/3. Okay? Well, in this lesson, you really have to deal with fractions. There's no way out, but that's fine. So basically, what I have here, because I have the same base. If you got noticed, did you notice that we have the same base here? Same base. So we just have to add the powers. So in this case, I'm going to say 81. Then I have 5/6 minus 1/3. I just said adding the power. How come I have a negative? Well, because this guy's negative. So you could, if you like, you put plus minus negative, which means negative. So now you have to have a common denominator here. This dude has to be multiplied by 2, which now means I have 81. And I have 5/6 minus 2/6. And this would give me 81 raised to 3/6. Well, 3/6 is 1/2. And what do you think is that root? If I want to go from here to the root, what root would that be? Cubic root? Fourth root? What's this root here? Square root. It's very true. Square root of 81, which is how much? What's the square root of 81? 9. Okay? So once again, the big deal here was just a fraction, by the way. If this was just simple whole numbers, we wouldn't have spent too much time on it. But it was a fraction, so it's good. A little bit chubbier example, I should say, is going to come up in a second. A little bit chubbier example. Example 2. This one goes like, I've got x, y cubed over, oh my gosh, x to the 1/2. The whole thing is raised to 2/3. What are you saying? Okay, don't worry, relax, chillax. Here's what we're gonna do. We're gonna again divide and conquer. So there is multiple ways to do it. You're either gonna distribute this here right off the bat, like the first step, 2/3 to every one of them, or deal with what's similar inside the parentheses. That's what I would rather do. Deal with what's inside the parentheses first. So I basically have here in my mind, there's an x at the top divided by x to the 1/2 power. Well, if you know the quotient property, remember the quotient property? This would mean, because it's the same base, x, 1, there's a 1 here, right? Minus 1/2. Which means I have basically x to the half. I have x to the half. Okay, so if I combine these two x's, I'm going to end up with x to the half. That's exactly what I'm going to do. X to the 1/2 power times y cubed. Do I divide it by anything? No, because you already got rid of that. The x to the half here at the bottom, you already have dealt with it with the x at the 1 at the top. So now I distribute the power. This 2/3 is going to belong to here and to here as well. Remember, this is a power here. Maybe I should make it a little bit smaller. This is a power outside 2/3. 2/3. So now I got x 1/2 times 2/3. Then I've got the y 3/3 times 2/3. Well, x 1/2 times 2/3, I see here that I could use my fruit ninja and just chop. I could chop this. That's going to leave me with x to the 1/3. How about this dude here? You could make this guy a fraction and chop again. So basically what I end up with here is x. Let me make this darker, thicker. X to 1/3 times the y is raised to what power? Y to the second power. X to 1/3 and y to the second power. The 1/3, if you do not want to leave it as a fraction, obviously you could put that as a cubic root, right? Because 1/3 is a cubic root. So if you would just want to be a little bit fancy, you could put x like that, and then the y squared. And that should be your answer for this problem. Okay. Also, because it's more appropriate, I guess, in math to start with something and then you add the radical. So you also might want to have it like this as always, okay? It's just a different way to represent it. It's the same. It's just more appropriate to be presented that way. So you start with y, and then you basically leave the radical until the end of the problem. You leave the radical until the end of the problem. And let me use a lighter color for this one so you can see. Okay, champions. I'm gonna pause here. I think we got enough today, and we shall continue this journey next time. Don't forget to, once again, to subscribe and smash the like button and share with somebody who might need it. You could like the video. You don't have to like the math, but you could like the video. All right, you guys, you're awesome. Be blessed and take care of yourselves. Until I see you next time.